In our last session, we discussed on insulation coordination study, and from that, the conclusion we arrived is the calculation of the face to ground and face to face clearances, right? So we got a face to ground clearance as well as the face to face clearance. So how I got this with respect to the BIL levels, BIL by 526 or the maximum of the maximum of BIL by 526 or 8 by 4024 by BSL minus 1 will gives me the single face to ground clearances. And if I want to face, 1.1 times of his face to ground, I will get. Right, team? So this point we understood. Fine. So now we have to prepare in our today's session. Let's prepare the layout for our substation. Layout for the substation. So again, I am pointing here that the layout is not a standard way of design. You can design the layout on your in your creative way. And again, it depends upon the standard practices you have to comply with respect to of your local statutory bodies or local bodies. In a simple way, I will talk this in a next while. Give me a minute for this. Fine. So to prepare a layout, generally we need to know the clearances. So clearances from the earth. So obviously it's a face to ground clearances and clearances between the faces, like face to faces. Generally, the clearances from the earth, from the ground, actually I required depends upon the factors like the voltage class, height of the person, height of the footings, and depth of the suppose the snow, all these things, right? And also I have to consider the clearances with respect to the vehicle movement in the substation, and clearances I have to check with respect to the fences or substation buildings or working clearances. So to do this or to do all these things, generally the main important two things are the face to ground and face to face clearances. And apart from these two, we are having two more clearances. One is a sectional clearance, sectional clearances. Sectional clearances. Other one is the ground clearances. Sectional clearances and the ground clearances. What is a sectional clearances? A sectional clearances ensure a person to work on the one section when other section is in charged condition. In a simple way, let's see, I'm talking about the sectional clearances and the ground clearances, which again depends on the face to face and the face to earth, which are the fundamental things. Now I'm talking about the sectional clearances. Sectional clearances. So let's see, I am having this is my isolator. I'm not giving some foundation. I will talk that foundation afterwards. Let's suppose this is my isolator and this is my breaker. But I'm talking about our 33 kV SLD. The first one is the lightning arrestor, isolator, breaker, CT, isolator, right? Same. So this is my lightning arrestor. This is my isolator connecting to this. Isolator connected to the breaker and breaker connected to the CT. And the CT is again connected to the isolator. And this isolator connected to the bus. So isolator again having three stands because our is a double bus isolator. So this is the plate which is closed. The isolators are in closed position. Okay, this is a simple way. So the red line at the bottom is the ground. So this is the ground, suppose. So when I want to do this, sorry. Let's draw again. This is the ground. I'm having an equipment of lightning arrestor, which is always connected to the parallel, and it's connected isolator. This is the isolator connected to the breaker, and this breaker is connected to the CT, which is the tank. This one is the tank, let's suppose, and the CT is connected to the isolator again, and I am having a isolators. So this is the blade. This is the blade. Now let's see, team. So this is the phase 2 earth clearances to be maintained. Suppose if I am talking about the 33 kV system, the phase 2 earth clearance is, what is the 33 kV PIL? 170. 170 by 526 gives me nearly 343 mm. That what we have seen in the yesterday's book, right? And which is nearly 350 mm, suppose. So the minimum clearance is this, but suppose let's assume that this is the minimum clearances to be maintained, a 400 mm, and this is a single phase. Now I am talking about the sectional clearances. The sectional clearance, the sectional clearances mean a person should ensure to work on that system, on the section, when the other section is in the charged condition. When other section is in the charged condition. That is the sectional clearances. I mean, suppose let's assume mostly where the maintenance activities are come up on the breaker. So a person taken some ladder and he climbed to this platform and he's doing a work on this breaker. He's doing a work on this breaker. So when the breaker is, when he is working on the breaker, what is the condition we are checking? This person should not expose to the nearby live pot. Nearby live pot in the sense could be the next phase or could be the same phase. In the same phase, when I am operating the breaker, when I am doing the maintenance of this breaker, both the isolators obviously in the open position. So the now live pot is up to here only. This is the live pot for this person, and this is the live pot for this person. This is the live pot. So this is the person, and this is the phase. This is the earthed, which is ladder is earthed, earth connected to earth. So this is earth. The person is also earthed. So phase, earth, maybe this is the, suppose this is a one case, maybe some cases the buses is traveling, the live bus is traveling on the top. So suppose the person who stand and working here may stretch his hands towards the sky or towards the left. So the height of the person is also we will consider, suppose let's as a maximum we are considering as a 2.5 meters and a margin of 0.5 meters plus phase 2 earth clearance gives you the 33 kV sectional clearances. So what is the how much forward should be from this? 2.5 plus 0.5. What is sectional clearance? 500 mm, let's suppose 0.5. So 2.5 plus 1, so 3.5 meters. So the distance between this one to here, it should be 3.5 meters. That is the one case. Other case is when breakers generally will, some breakers will fail. So when it's failing, the breaker, when it explode, so it should not damage the other adjacent equipments. So based on these two factors, we maintain the distance between these equipments still. That is the reason of this. Sectional clearances, and as per a safety point of view, we will maintain a distance from this breaker towards the adjacent breakers and the equipment to the equipment. That is the point. Clear, team? Understood? Ashish and Ahmad? Yes. So this is the sectional clearances. What is the formula? 2.5 meters, which is the height of the person stretching his hands or having any tools in the with him, plus 0.5 as a margin and plus face to earth. This is the sectional clearances formula. And one more clearance. So what sectional clearance is saying? When a person attending a work at here, he should ensure, I'm ensuring that person can do a work on this section when the other section is in charged condition. Maybe this, maybe that other phase or that phase, maybe. So this is the chance of, this is the sectional clearances. So, but the face-to-face clearances, Santosh, we are maintaining only 1.5 meters. Then how? If I am doing any maintenance work on one phase, obviously the total feeder will be off, right? You cannot run other two phases with one phase in shutdown. So whole feeder should be shut down if you are attending this. So when it will come, if one phase of this feeder is having you should maintain a distance of other section where it is in a charged condition. So what is that clearances? Is this 2.5 meters plus 0.5 meters plus face to earth clearance. That is a sectional clearances. Very important. These important. These are the some. Sorry. These are the some important points or terminologies. Generally, we have to note in when in interviews. These are the main questions they will ask, and you will get impression at that time itself when you answer these types, because mostly no one knows these type of why we are maintaining the sectional clearances and safety clearances. They are generally talk about the face to face and face to earth. They don't know about the sectional clearances and the ground clearances. It is good if you talk about these also in the interview when they are asking questions on the layout. Definitely, you will get a question on the layout when you are facing the interview for the substation designing. Okay, keep aside. So the next one is the ground clearances. So the ground clearances is okay. What I said, the phase to earth clearance, I am maintaining 500 mm. That is fine for me. So I am maintaining with placing an insulator on the soil itself. But maybe tomorrow the person is walking in this substation may accidentally hit this insulators. So insulator will damage and it will create a fault. Insulators are a sensitive equipment, right? So what I have to do, I have to place these insulators that should not be in hand approach by the hand of the person. In a simple way, I have to ensure that any person working in this area cannot touch or damage the insulators accidentally. So to do that, I have to maintain some height on this. So what is the height to be maintained? That is the ground clearance. What is the ground clearance then? Formula 2.5 meters plus insulator creepage distance, which is 25 mm per kV if your substation is in a moderate level. Otherwise, if it is a heavy polluted areas, then insulation is 31.5 mm per kV. It is a light polluted areas, 18 mm per kV. These are the three creepage distances we are having in the insulators. So this will gives you, and if you want to take some margin, or suppose for the CT tank gap is there. If it is a tank is on the bottom, dead tank. So dead tank will come into the picture. So this will gives you the ground clearances to be maintained. So how you maintain this? By placing some structure to this. So on the top of the structure, you are installing this lightning arrestor or the isolator to meet the ground clearance. So they will ask you a question, why you are placing the structures at a height of this? To maintain the ground clearance. That's the way of explanation on this. To maintain the ground clearance, I am placing the isolators on the top of this, some lattice structure or a pipe structures. So how to calculate this? 2.5 meters, again, the height of the person by stretching his hands or tools on towards the sky, plus 25 mm per kV. So suppose the 33 kV, 33 into 25, how much it is? Divided by 1000. It's nearly 2. 33 into 25, 825, 0.825. So 2.5 plus 0.825, nearly 3.3 meters or somewhat. So 3.5 meters. So the height to be maintained from here to this is 3.5 meters for 33 kV. And if you see for 220 kV, it is 5.5 meters. 220 kV, generally the ground clearances we generally will meet is 5.5 meters. Again, the calculation is simple. It's the same calculation. So by knowing the ground clearance, by knowing the sectional clearance, by knowing the face-to-face clearance, by knowing the face-to-ground clearance, I will prepare a layout. I can prepare a layout. Again, subject to what the utility standards and the what are the structure design you are having for that project. Suppose let's go to our layout. Let me share you this. Team, are you able to see the single line diagram?
Yes.
Okay. So this is the 33 kV lines which are incoming, and this is the bus metering arrangement, and connecting to the bus, and this is the coupler, and two transformers are connected again a bus, and this is the sectionalizer at 220 kV for a metering purpose, and two lines are going out, and this is a bus coupler. This is the SLD. So layout is not a standard one, team. So no need to memorize the layout. Just you should know the concept. Next, if you want to build, you can build again. Depend upon your availability of the structures. What I mean is, let's talk my design for this project. I prepared a layout. This is the layout what I prepared. What? Let's see. If you just see, these are all my 33 kV feeders. 1, 2, 3, 4, 5 connected to a bus. 2 meters connecting a bus. And I forgot here the sectionalizer is there, but in this I skipped this. Here the sectionalizer will come, and the two transformers are connecting to a single bus. This will not be there. Only one sectionalizer will coming and connecting to the double bus, and two lines are going out, and this is the bus coupler. This is the bus coupler. So this is the layout I prepared. And if you see the distance between the equipments to equipments here in in 33 kV, the equipment spacing generally we are placing 3 meters spacing. And if you see in 400 kV, it comes to nearly 4 meters. For the breaker, it is 5 meters isolators. This is the clearances between the equipment to equipment. And if you see the face-to-face clearances in 33 kV, here the face-to-face clearance is 1.5, 1.5, and 1.5, 1.5. So total bay width is 6 meters. And if you see for 220 kV, the face-to-face clearances is 4.5 meters, 4.5 meters, and 4 meters, 4 meters. So total bay width is 17 meters. What we have seen in the CBIP manual yesterday. Now, I am doing the design this way. So how I am doing? So this will come. This is the This is the project we done in some Andhra Pradesh state regions. Here we can use these type of towers to accommodate the lightning arrestor and the isolator on the same structure. The same design, the same structure design, not there in Karnataka, Madhya Pradesh, and Rajasthan regions. There you have to have a separate structures for lightning arrestor, isolators, everything. So it's totally changed from project to project. I mean, so there is a no much detailed explanation on this. Just I want to show you how to read, how to study this after this class. If you want to just go through this, how to see this. Let's see. This is my single line diagram. This is the way lightning arrestor. This is connected to the bus. The same one is this. And if you want to know how they are connected, again go to the next document, which is a sectional views. Will show you the ground clearances and sectional clearances. This is the one. If you see here, this feeder, the line is connected to this boom, and from here the lightning arrestor cap and the isolator is also placed on the same boom at on the same structure at the other level of at other level, and from this CT breaker connecting. These are the structures I am using. And again, these are all the for metering elements. Present, I am using PIs and isolator and connecting to the bus. This is this part. I mean, this part and including this part. That's what I shown in the layout. If you see the layout, this entire part I have shown as a EE. EE represents, if you want to look into this, how it is connected, just refer EE in the sections. So come to the section EE, you will find how they are connected. And similarly, if you see how the from this bus to how it is connected up to the transformer up to this level, means how this one connected from here to this level to here, this total stretch, how it is connected. So for this, which I have to refer? I have to refer D. Come to the sections, go to the D. Yeah, if you see here, this is the 33 kV again connecting, and it's for the road crossing. We are placing some. We have to give a provision for the road adjacent to the transformer, because if you want to take the transformer for the factory for any repair issues, then easily you can pull the transformers. So beside the transformers there should be a road connectivity. That's what you can show in the this layout. This is the road. So, and this transformer is connected to the bus, single bus, and LA, CT, breaker, isolator is connecting to the bus, and from this bus again isolator is connected to the PT. That's what I have shown here up to here level, and the same you can see in the sectional basis. This one. And now if you want to see this part, how this from here it is connected to the double bus, then just again go to this layout and see how to find that stretch. It asking us to refer C to C stretch. Go to the C, this part. So this is a single bus. From the single bus, all the CT meterings all connected. And if you see, this conductor is going to the top and it's coming like this and connecting to the this bus and again connecting to the this bus. So this bus we will call as a jack bus. What we discussed in our past classes, jack bus, where we are running at some high level. So this is will call as a jack buses. These are the main buses. To connect to the bow, this is the arrangement I have used by using these structures. This is the way of design. And if you want to look into that, how these lines are connected and the bus coupler connected, again refer to the line arch, which is A, and bus coupler is B. Come to the A, which is the line. This is the line out. Sorry. This is the line out connecting to the grid substation, the lightning arrestor, CVT, and these transformers. connecting, and again going to the top to the jack bus and dropping here, and with isolators connecting to this bus and to this bus. And if you see the bus coupler, same. This bus connected isolator CT, breaker CT, going top, coming again to the back and connecting to these two buses. So layout is totally different team. So you can do the design of layout on your own. It's totally depends upon your creativity. How you want to do, we can do. Again, based on the inputs you are having. Clear team? So layout you cannot learn without practicing it. So only you can see is how these are connected, just to know, and what is the fundamental concept to we have to do before to do this layout. That's what we discussed on insulation coordination study on finding out the BIL, BSL levels and finding out the face-to-face clearances or all these ground clearances, sectional clearances, everything. So layout sectional views will you can prepare after doing 3-4 projects only. In now itself you cannot do. No one can do. It's totally on practice by using those different types of structures for in that utility. I mean that in Uttar Pradesh in Uttar Pradesh state, they are using different towers. So with you, by using those towers, you can this total layout will change definitely. And if you see in the if you look into the Rajasthan projects, they are using tandem isolators. So that gives a different type of layout. In Karnataka regions, you can see this isolator is here, right? These isolators can be placed on like this. I mean, it is like underhung isolators. They will place isolators like this. And instead of taking this CT from here, they will take all the cities before only and they will take that like this connection. Underhung isolators, which is restricted to use in Andhra Pradesh and Telangana projects. So it's totally depends upon the project to project, utility to utility. So as electrical design engineer, we should know the concept and the theory behind this. That's it. No need to memorize all these layouts. Definitely, all will. Even if I don't know how the layout in the Bihar state and Uttar Pradesh states, because I have not done any projects there. If I am attending the project there, again, this is a new for me. I have to comply to those standards. Even if I'm having 50 years of experience, again, it's new to me because I don't know how they are connecting, what type of structures they are using. So I will get the data from the respective nearby substations or grid substations. And based on that, I will design the system again. Layout, definitely you have to rely on the grid substation person. So if you ask him, he will send you those drawings. So you can use those structures and you can design on your. Understood, team? Clear? Ahmed, Ashish,
Yes,
Ashwin?
sir.
Yes. So it's a no one can do. It's a simple way. You have to know what type of structures. Suppose if I am having this one, if I am doing the same setup for Uttar Pradesh state, they will reject this because they are not having these type of towers. They are not having in their projects. For them, there are different types of structures. We have to use those structures.
These are the AutoCAD drawings, no, sir?
Yes, sir. These are the AutoCAD drawings.
So these are done by the draftsman, right? Not by us, I believe so.
Yes. These are done by the draftsman, but you have to give the sketch to him.
Sketching, like rough sketching.
Rough sketch. You don't believe, you won't believe all these drawings done by myself only. I am the engineer, I am the draft person. in my projects.
Okay.
Yes, I will share you the AutoCAD drawings of these also. So it would be helpful for you in future reference, just for copy paste kind of thing, if you want. But
We
it's
do a
better.
lot of copy paste in our job.
Yes, sir. Yes, sir. Obviously, because in electrical, see, all these are same only, right? If
Yeah.
220 kV project is there, we copy all these things and we'll paste here. So there is a, so if I'm asking engineers, I am taking interviews for some candidates who are nearly 12 years of experience, less greater than me. At the time when I'm taking the interviews, I am holding only 6 years of experience. Then I am asking them question that they don't know what experience I am having, because I am inside the board. They don't know. So when I'm asking a question them that have you done any layouts? Yes, I have done the layouts, and he will say each and everything. We have to maintain road width of 7 meters for before the transformer, and we have to place a high HPPI, which is a high bus post insulators to avoid the lifting of my transformer connections. Here you can see this is the HPPI, which is acting as support. Otherwise, if I'm taking directly to this, what will happen? It will that will come out, right? So to avoid that, I am placing again some kind of support to here. So they will say all these things. But next, when I'm asking a question that, okay, so before doing this, what is the concept we need to do for the layout? Then I have seen from suppose if I interview 10 candidates, 10 candidates said that, so it's totally depends on the utility board approval, sir. So that's the only thing they know. But what is a fundamental fact? What is the concept behind this? No one knows. Really, trust me. But I don't know. Maybe whom I interviewed. Who I interview, they don't know. Maybe other know. Mostly, even my colleagues also don't know on this. The concept is this. That was mentioned in the IEEE 1427. So no one in the electrical system design field will go through this standards thing unless they are doing the projects for abroad. I too, when I am working in my organization, I do mostly I also doing the copy paste. So by doing the copy paste, what I came to know is, oh, I am very expert in the substation design. Then my one of the friend is there in some Middle East, and he has given some freelancing works to me. And when I'm attending those, then when I'm seeing their drawings, everything, those are very quite different from us. And in those, when they are giving some quote, right, quotation, in that quotation, I have seen we want for each and everything, they want a calculation, justification. They asked me a question, Santosh, why you placed 1.5 meters of face-to-face clearances in 33 kV? At that time, what I know, we are placing 33 kV 1.5 years, so I placed it there. That's the answer with me. But they won't allow, right? So then I have studied all these triple documents, and I have taken some suggestions from the old people, not who are having 15 years, 16 years. I have taken the suggestions from the person having 30 years, 40 years of experience. So they know all these things. In the middle, all came with a copy paste type. Now also all doing copy paste only. So I have learned from him, and then I will come to know this. This is the things we have to see. In abroad process, definitely you need to do all these things still. They are mostly ask you to give the justification for each and everything. Yeah, cool. So that's this about this layout team. So if any doubts, team? Ashwin, no, right?
No, sir.
Ashish?
No, sir.
Okay, cool, fine. So this is the one about the layout team. And here again, I want to explain some concept, which is a clamps and connectors to be used to make it in this shape. I mean that suppose I am connecting the conductors from equipment to equipment, right? And I am stringing these conductors on the buses. If you see this, I am using some type of connectors. So in the substations, we are having two types. One are clamps, other one is the hardware, third one is the connectors. Connectors are which come at the equipment level. So this conductor is connecting to this equipment. So this isolator should have it some terminal connector. We will call this as a terminal connector. So these terminal connectors you can purchase from the manufacturer of isolator, or you can purchase those as a separately by indicating the type of the conductor you are using here to connect for the isolator. I mean that suppose I'm talking about the connector thing. Suppose this is the isolator, and what is the conductor I'm using? Yes, single triple AC MOS. So for entire this stretch, I have to say that vendor or the manufacturer that I required one two two terminal connectors per phase, two terminal connectors per phase, which are suitable for single triple AC use. So if I mention this, he know what is the size required. So by this, the hole where this connector, actually this connectors could be like this, right? This will be connected to this with some bolts or with like a welded type. So this conductor, which is a round shape, should insert into this and should be clamped. So this dia of that connector and the dia of this conductor should be nearly to be same, or the conductor should be somewhat less, not should be more. So he will provide that dia with respect to the conductor you mentioned. So these are the terminal connectors. So if you see how many terminal connectors will come for the isolator. For isolator, 1, 2, 3, 4, 5, 6, 6 connectors will come, because our isolator is a double breaker, double bus, double break isolator, horizontal double break isolator, or double break central rotate isolator. So we are having three limbs, 1, 2, 3. If you see from the top, we are having the isolator is like this. Now this one is you are viewing it from this side. So this is the R phase, Y phase, and B phase. So 1, 2, 3, 4, 5, 6. So each isolator required 6 terminal connectors, and each breaker in the circuit requires again how many? 1, 2, 3, 4, 5, 6. 6 connectors. And again for the CT, 1, 2, 3, 4, 5, 6. So each phase we required connectors. Understood, team? So again, we have to mention these terminal connectors. Just I required a terminal connector that should be suitable for single triple AC. That's about the terminal connectors. Terminal connectors will come for at all the places of where you are connecting the equipment, the conductor to the equipment. There you can see the terminal connectors. Next one is the clamps. What is the clamps? The clamp. So before going to the clamps, let's talk about the hardware. Hardware is, let's see, Oh. Hardware is, suppose this is my boom team. This is my boom. This is a boom. Now, a conductor should connect between these two towers like this, R, Y, B. And from this, it is connected. This is the ground. This is the ground. If you see in the 3D, it is at the ground. These are the three phases. Now, the equipments are will be here. The isolator. Suppose this is an isolator. This isolator having three limbs, which is connecting to these buses. Again, we are having three phases, right? So three phases, isolator connecting to this like this. Okay, this is isolator and this is the B phase isolator. If you see, this is the B phase and this is the B phase isolator connecting to this. And this is the R phase isolator and is connecting to this R phase isolator. And this is the Y phase isolator. This is the Y phase isolator. So like this, it's connected. Now, how can I connect this? With the connectors, with the clamps. And to run this conductor between the two structures, this is the phase. But the structure is some lattice structure. So if I'm connecting, it's creating some short. So I have to provide some insulator material here and to maintain some phase to earth clearances. And also I have to that insulator design should be capable to give a strength for to develop a tension between these conductor. I mean, to suppose if I am having, let's think, I am placing some rubber kind of thing here, and I placed a rubber here. So if I place it here, what will happen? This conductor may comes like this. So what I have to do? I have to tie it. I have to tie it tightly. I have to string this conductor tightly. So how can I string this conductor tightly? So you require some hardware here. You require some hardware here, which will keep your the conductor in a with a low sag string in erect position. So that we will call as a hardware. So it's creating in some tension and a hardware. So this will call as a tension insulator hardwares. Tension insulator. This is the tension insulators, and the hardware associated is a tension insulator hardware. And now this is the bus. Now this conductor should extend from this bus to the next bus. I am having a next bus here. Next bus here. I cannot string this conductor for 50 kilometers, for 30 meters, 100 meters. There should be some limitation for the conductor. If you see for a 220 kV, the limitation is 34 meters. The limitation is 34 meters in 220 kV. So after again, I am having one more bus. So this bus is connected again by having a tension insulators, what we discussed. But this bus is totally same bus. So I should connect this bus to this bus. So I am connecting this bus to this. So I am connecting like this. So for this support, I am placing again an insulator from the bottom. This insulator and associated hardware, we will call it as a suspension insulator hardware. We will call it as a suspension insulator hardware. This suspension insulator hardware is giving some support for this conductor to move from here to here. So when I am taking the conductor from here to here, I have to connect the conductor to the conductor here. I have to connect the conductor to conductor here. And isolators are connected to here. So these connections can be done with some clamps. What are the clamps available in the substation equipment? One is a T clamp. Other one is the wedge clamp. Generally, we can see these two type of clamps, wedge clamp and T clamp. PG clamp is also there. But these are the two widely used ones: wedge clamp and T clamp. So what is this T clamp? Suppose I am having a conductor. This is the conductor which is traveling on the top, which is ACSR mousse. I am having a conductor on the bottom, which is here. The equipment is there, lightning arrestor. The conductor I am taking, this one is ACSR Panther. ACSR Panther. So I have to choose a T connector, which is forming a T shape. So this T connector should be having a ACSR moves through, and a ACSR Panther drop. I will mention in the BOQ that a T clamp where ACSR moves is through and ACSR Panther is drop. I required three clamps of that specification for 3 phases. So this is the T connector. And suppose on top it's a twin mousse, and from the twin mousse I am connecting only single mousse. Again, the T connector that should be suitable for twin through, single drop. And if you are connecting these connectors in this way, here also you can see twin to single. This is a single, right? Single to single, single to single. This type of connectors also you can use. It again depends upon the requirement. Instead of twin to twin, suppose if I want twin to twin conductors, I want a twin mousse is there, and I want drop also twin mousse. So I can select twin twin or single to single, single to single connector. So when these type of connections, you can see this, when you are seeing a T shape, then you place a T connectors. When you are seeing a parallel connections, like this is the connector and one more connector. If you want to connect these two, then you are using a wedge clamp. Wedge clamp suitable for ACSR mousse. Wedge clamp suitable for ACS AAA mousse. It is only talking about a single conductor, right? So it's a wedge clamp. And so this is about the clamps, and this is about the hardware, and the connectors according to the equipment. So this is about the clamps, connectors, and the hardware. Clamps, T clamp and the wedge clamps. Connectors, for every equipment we are having the connectors. And the hardware, 2 hardwares are there. One is a tension hardware and there's a suspension hardware. Tension hardware is to use it to string the conductor between the 2 towers, and the suspension is giving some support to connect the conductor between the buses. Clear, team? I will show you some photos on this team. Let me share. Team, able to see the screen? Hello?
Yes, sir.
Yeah. So here you can see, team, these are the tension hardware. What I said for the using for the to string these conductors. These are the tension hardwares. And this is the clamp we are connecting to that one, to that boom. And from here, the conductor will go through this. We are tightly packed with these boards. We will lose these bolts. Let's see. we will lose these bolts. So this U shape will come up. So we will insert the conductor to this and we will run like this. And next, when the conductor inserted, then we will tight these bolts. And this is connected to that boom. And from here, the hardware will come. So this is how it is. This is the tension hardware. And if you see the clamps connectors, so these are the clamps. These are the T connectors. Sorry, connectors, which is used for the connecting this for the PT, for the parallel connection, for the lightning arrestor. These for the breaker and CTs and isolators. And see, if you want to see the T clamps and wedge clamps, this is the T clamp team. You can see the through and the drop T clamp, and wedge clamp is it's like this one. This is the wedge clamp. I'm inserting and I'm hammering it, so it will be fixed. Once the wedge clamp was fixed, the conductor will be tight. Again, no removal and nothing is possible here. Once we are doing it, it will be locked directly like this. See, and let me show you the bus stringing. Substation. Before I'm having so many pictures, my hardware I lost my hard disk. Because this, you can see here this is the this one insulator which is stringing within this. This we will call as a tension insulators. Tension insulator. This. See how it is connected. And this is suspension to form a bus. See how it is connected? Suspension, just to support. This is a tension. Like this, you can see here. This is a tension and tension to the both. This is a transmission line, I think. And the suspension insulator acting as a support to connect both. So you can see the tension here. You can see this tension insulator. This is the hardware. See, at sorry to I forgot to tell. See, at one end you can see normal. In other end, if you see the next end, there will be this type of structure. What I have shown, some buckle type of arrangement that we will call as a turnbuckle. I mean, it will be generally it will connect with like this. Suppose this is the insulator. Here the conductor will come like this. But other end, this insulator is connected to this. With this insulator, there is an arrangement of turnbuckle. What I have shown, like a gun type of arrangement. Why this? First of all, I will erect this. So to make it tight, I will pull the conductor, so it will tight. Then I will cramp it. Then I will cut the conductor. So one side you require a turnbuckle, other side not required. So when you are doing the BOQ also, you have to check that a tension insulator with a turnbuckle, without a turnbuckle. One set of turnbuckle, one set of without turnbuckle. Please remember that. So that's about this clamps and connectors stream. Clamps and connectors also very, very important because this will create a headache at the last commissioning stages. The clamps will not fit. So it's very, very important to when you are preparing the bill of material for the clamps and connectors, I have to check once or twice and thrice on this whether you have given a good size of clamps and connectors suitable for that conductor. If you are changing the conductor, you have to you should come that suppose finally you changed the conductor. It seems if you're changing the conductor, please be cautious that the clamps and connectors also will change. If you're not changing that, it will affect on your project timelines at last, because those are small type of small equipment. Generally we will not bother on this. Those will be in the store. At the time of commissioning, they will ask you to they will, at the time of erecting this, then we will notice, oh, this clamp will not suit for mine. So we have faced this type of issues at the time of commissioning. So it's very important to um, see the clamps and connectors when you are doing the project. Fine. So you can see here the turnbuckle is there. But at that end, you cannot see the turnbuckle.
Is there to choose the types of insulators?
Types of insulators in the sense we are having generally before we are using porcelain type, but present most of the projects they are going with a polymer only.
Okay. So any course and standard is allowed to use the polymer?
No standard. Standard in the sense, the standard won't speak that you should go only for the polymer for this, you should go only porcelain for this. That's our choice. But this polymer on porcelain insulators, the manufacturers, when they are designing this, they should comply to the standards. Those standards let me see. Insulators, the standard is post insulators. Mhm. I will share you this team. Let's have a look. It's a very interesting how to size. It's not required for us. It is a part of insulator manufacturer, but let's have some understanding of this. This is a 250 kV one. Here only ANSI standard was written, but EC standard is there. EC standard. Let me see. The standard is IS 731. If IEC is 60383. IS 13134 is also applicable for this. IEC 601815 is also applicable for insulator, porcelain insulator selection. Fine, Ashish.
Okay, sir.
Yes. If you want a major one, IEC 61109. 61109 IEC.
Okay.
Fine. So I will share you this also to you. Have a look on this. And one more important thing also I want to share you. Stop these clamps. Having that, let's see that whether I'm having that. I will check and I will share you. Then.